not only does it help you guys, the students, but it does help the businesses because interns or even part-time students generally make half of what, or 3/4 the pay of what full-time employees do.
Factor in like what they pay in benefits to on the back end for them?
Oh, definitely, yeah. All that factors in. But you know, what's great about it is, in my experience with interns, or even if you start on intern or part-time, is that 90% of the students, in the last 3 years I've been keeping track, 90% of the students that have gotten internships through our division that I've had a part of personally, had a part of helping, were offered full-time positions. 90%. That's pretty high. That's a pretty high percentage. And that speaks a lot for our students. That speaks a lot for our division. And so, yeah, I think the track record is there. Were you guys needing that pen up there still? Okay. 5G5 8M9. 5G5 8M9. Everybody got that? Okay. All right. So that's my little spiel. If you have any questions, you can see me after class. Be more glad to help you with that. Thursday, we're going to be doing the lab on, I'm going to give you some information on WebCrack. I'm going to be doing one before the class and videoing some of it because it takes a while to do this one. But I'm going to do a video of it, and what I did last semester worked pretty good. That way you guys see how long it takes for I think it's a 4 or 5 character password, how long it takes to crack a web password. Talk about the software used, the steps to how to do it, and how it's done and how you can guard against it from happening on your network. And then we'll be doing a lab, though, on IE security settings, where you can go into IE and you can block downloads, URLs. You can even block certain game platforms, like, say, rated, M for mature, NC-17. You can also block movies, music, even social media. The last one we'll play with the most at the end of the lab, which is gpedit.msc command. It's the group policy editor where you can go in and lock out certain features in Windows to where folks can't go in and do, like, change a setting that you just set in IE, or to save something to their desktop, or to install a program. You can block all those things from gpedit.msc on a local PC from Windows XP Service Pack 1 all the way to present day. In fact, I think the Windows 98, the latest edition of Windows 98, you could do it as well. I'll give you some warnings on that, so don't play with that between now and then, because you can lock yourself out of your PC. So I'll give you some tips on that on gpedit, but it is a powerful tool within Windows when you're setting up Windows for a business environment. Do I?
I did that once when I was little. I locked myself out by trying to screw with those settings.
Yeah, you can. I've done that before when I was learning it. On control panel, I wanted initially just to block people from getting to certain areas of control panel, like either adding a printer or something, or installing software. And I did something else while I was playing with it. And when I got out of Windows and logged off, I couldn't get back in. So I locked myself out totally. And so I'll show you some tips and tricks to help you from that happening, stop it from that happening. I'll show you how I learned to stop that from happening over a period of time of pulling my hair out. So that's a fun one. And review questions for week 6, quiz as always. There's a video here on wireless security we'll go over. You can watch that prior if you want to, as always. Okay, so how many of you have Wi-Fi at home? Or you've set Wi-Fi up, or you've done both? You set Wi-Fi up and you have it at home, right? Okay. Well, this goes over some of the basics of Wi-Fi and what the security protocols are currently in Wi-Fi and where we're going with it. 802.11 is a term you'll hear a lot in Wi-Fi security, and that is basically a protocol to apply protection, authentication, and such to Wi-Fi. WEP we'll talk about, WPA, WPA2. These are all terms within Wi-Fi security. So 802.11 started in the IEEE, which is the Institute of Electrical and Electronic Engineers, most widely known, influential organization. I think I mentioned this a while back. If I didn't, I'll mention it now. IEEE does have a student chapter here in Rockford and in the Chicago region. You can go to IEEE.org, click on the student chapter or the student link, sign up. You get a magazine, get a lot of free resources. They also have job postings on theirs too, so that's another job source, I guess, for you. And so they have a number of competitions throughout the year. Most of them are in the Chicago region, but no students that have done that in my classes in the past that liked it. And so it's nothing you're forced to do or I require you to do, but definitely recommend you look into it if you want to, see what's on the website, see what's available for you as a student, because you do get stuff free that you don't get once you graduate and are no longer a student. And so it's well worth taking your time to go there and spending 10, 15 minutes on the site. So in the early 80s, IEEE began to work on developing computer networking standards. It was called Project 802 originally. In 1990, they formed a committee to develop standards for the WLAN. They operated at a screaming 1 and 2 million bits per second. It's kind of like dial-up days of wireless, very slow, but it worked, and it was the first time it ever did work. So you can imagine pretty excited when they got it to actually work and it was functioning. So because of that, they knew they needed some standards, some security to wrap around it. Because originally when wireless was used, it was open, which a lot of stuff is when it's R&D, no security around it. So before they could push it to the public, like your guys' routers at home, they had to knew they were going to have some security around this protocol. So it began with 802.11a was the very first standard, and then B came around, then G. Now we're currently on the N, which most of you have at home, I'm guessing. If you bought a Wi-Fi router in the last, I don't know, 2-3 years, you probably have an N router. And we'll talk about the different terms, like mixed mode is a term you'll hear in your router here when you're setting up Wi-Fi access points, and what those all mean. So basic reason for these standards we're controlling access within a Wi-Fi environment. And basically you can limit them by a number of ways, just like you can limit them access on a wired unit, a wired network. You can limit access through MAC address filtering, where you have a pool of MAC addresses and only these MAC addresses can connect to your access point. You can limit by IP address, you can limit by IP range, a number of different features. But by restricting access to the access point, only those devices that can see them or can connect to them can become a part of that network. Most of you have under 5 computers at home that are on your Wi-Fi network, but I guarantee you most of you have a pool of IP addresses of probably about 50 if you've not changed it since you've set it up. Because that's the default, 50 to 100 is the default IP range that they give you, which I have no clue why they do that for home routers, but anyway, they've always done that. Because most of you, I'm guessing, have underneath 5. So I was always for, one of the standards I'd like to see in commercial routers is to have a 5 range of IP addresses. And then if they need to change it, they can. They can change the range. What I mean by that is you literally have, most of you, available slots of 50 connections available to you in your access point, which you're never going to use. Okay? And so one way to limit is to limit those ranges we'll talk about later. IEEE 802.11 standard does not specify how to implement controlling access. So they don't basically tell you how to do it. They just say, here's some stuff you can do. You decide what to do. Up to a couple of years ago, setting up access points was kind of the wild, wild west. Every business did it different. It has kind of got standardized with the WPA2 enterprise in the last year or two. But before that, every place you went to, a business that had Wi-Fi access points was totally different setup. Every one of them. Every one of them. And we'll talk about some of the valid reasons why that was so, and why that is so even maybe today. Almost all access point vendors implement control through MAC address filtering. Now, we've already learned in a lab already that you can spoof a MAC address and you can fake out access points. That's one way just to know, even though MAC is filtered on an access point, meaning you have a list of 5 MAC addresses on a access point configuration screen, like say Linksys or Cisco, or whatever you have at home, Netgear. It's not to say a hacker couldn't find out a MAC address within your range easily, spoof a MAC address on their laptop and get into your access point, okay? We've seen how that can be done already. There are some things that guard against that, and I believe we talked about that last week or week before last. It was week before last, actually, when we did the cloning lab of IP. Does anybody remember what it is on your Wi-Fi routers? What protocols on your routers that kind of mask and fakes out your IP address and MAC address to the outside world? Remember what that is? What was that?
NAT.
What was it?
NAT.
NAT, right. NAT is a terminology, or it's a protocol on all your Wi-Fi routers. Unless you've turned it off, it's on by default. It's already on. So the outside users, outside of your network, when they see your IP address, if it's set up through NAT, it's going to be a different IP address than the real one. Same thing with MAC addresses. The newest NAT also will mimic a different MAC address as well, or create a different MAC address for that device. So almost all access point have the MAC address filtering, whether it be, like I said, Cisco's probably the number one, and then you've got also Belkin is another popular one, probably the top 2. Cisco owns Linksys, by the way, if you didn't know that already. So basically you have Cisco, Linksys, and Belkin. Netgear's another one, pretty popular, not as popular as the rest, but Netgear's still around. So here we have a screen of an access point casting out its SSID and distributing it to 2 laptops here. It's also connected to a wired network, which is common. In our campus here, we have it 2 separate. We have a wireless set up on a subnet that's totally separate from the wired. So they are 2 separate network ranges. But this is a common setup of an access point. So when you're home, in your home, if you have a wired computer connected to your maybe 4-port wireless router, and most of you do have 4 ports on the back of your wireless router, you probably never use them, but you have available to you those ports. So if you have like a web server at home or you have a web server at work, you would connect it through a hard wire. I wouldn't recommend wireless web server or a wireless even gaming system. Gaming systems work much better via Ethernet connected to your wireless router through an actual wired Ethernet cord versus wireless. Because 9 times out of 10 when students say, I'm having problems with my connection at home with my gaming system, I'll say, is it wireless? Yeah. It's got set up wireless on the system. Wii, whatever, Xbox 360, doesn't matter. I tell them just connect it through Ethernet, set up that way. They come back the next day, woo, it's screaming. Yeah, it's a lot faster, isn't it? It's a lot faster. Much faster wired than wireless. We're getting there, but it's still much faster. To me, wireless is more about convenience and speed for sure than, and it's more about convenience than security even today, sad to say. It's getting there, but it's still not the most, it's not as secure as wired as yet. Here's some ways that screenshot gives of preventing or enabling PCs from coming in. This is a Linksys, it actually says underneath there, a division of Cisco, I believe, on Linksys there. So if your router is set up already at home and it's been there for a while, if, say, this was your router screen and you clicked on this Edit MAC filter list, all your devices are already in there. It's already got them logged after being in the router and connected for over 24 hours. More than likely has a log of all the computers you've had on your network over the last umpteen months or year or whatever. And so you don't have to manually type in that list. It's already more than likely already there for you. So one of the ways you can control access is by clicking on that permit only, clicking on the edit MAC address filtering list and checking the ones that you want in, and then the other ones will not be let in. MAC address filtering usually implemented by permitting instead of preventing. And so you only select those in the whitelist that you want in, not a blacklist of what you don't want in. Does that make sense? In network security and even networking, the terminologies you'll hear a lot is whitelist and blacklist. Whitelist means, in anything in networking, here's a list of stuff, of machines that can do this. Everything else that's not on this list is on the blacklist, basically. Or the other way you don't want to do it is a blacklist scenario, which is I have to keep adding machines or systems to this blacklist every day, which would be a nightmare. So it's easier to set up a whitelist scenario than a blacklist scenario. Does that make sense? On anything when it comes to networking and networking security. And that's the way the MAC address filtering basically is set up on your routers, as a whitelist. So WEP is the very first security protocol within wireless. It's designed to ensure only authorized parties to view wireless information. It does use encryption to protect the traffic. It met this criteria and still does today. The first term in any criteria is the main reason for this, or the main part of the security. The first term in this one is efficient. It is efficient, exportable, optional, self-synchronizing, and reasonably strong. And you'll find out from the lab on Thursday when I show you the video of the WEP crack. Unless you have a very difficult password, which most people don't, most people's passwords on Wi-Fi devices are for about 5 characters. 5 characters is the minimal for WEP. You have to have a 5-character password. They can be cracked. If it's all letters, it can be cracked in under 10 seconds, some of them. All right? If it has numbers and letters, that increases the time it takes to crack them. So it's efficient, definitely. And the reason WEP is still used in some environments and not the other ones we'll talk about in a second is because older NIC cards sometimes do not, or not sometimes, they will not work on WPA security, the newest security, WPA2, WPA. They won't work on them. So I'm talking about if you have a laptop that's 5 years old, that has a NIC card in it that still works, it's not going to work with WPA, WPA2. Not going to work. It's an older NIC card. It's an older device. The protocols weren't even out there to implement in that NIC card at that time. Does that make sense? So you have to use a security that is the weakest link in your environment has to be the security you set for your environment in Wi-Fi. Does that make sense? Because for compatibility purposes, if you have WPA2, say, enterprise, that we'll talk about in a second, on your network, if it works for 80% of your devices, not going to work. Make sense? Not going to work. So what some businesses have done is they say, okay, this access point has WPA2 enterprise, this access point is going to have WEP. But guess what? Both get into your network. Could get into your network, in essence. Does that make sense? So really the best way in my mind, if you're going to use it in a business environment, upgrade your devices to be on the strongest security you can get. That's what I recommend. And that's what I've recommended to businesses and implemented in businesses. Because if you go the other route, again, because of Wi-Fi, the way it's set up and the security, you have to set up your security in Wi-Fi for the weakest link in the system. Okay? And so that's not good. And so the best thing to do is upgrade the hardware to connect to the newest and greatest security. So WEP has been around for a while. It's the very first one. It has what's called shared secrets, shared secret keys, minimum of 64 bits. You can have a 64-bit, 128-bit, or a passphrase. Most people use the passphrase. Passphrases have to be at least 5 characters minimum, and most businesses, when they started this, it was a 5-character and then a phone number, which is 3, 3, and 4, 10. So 5 or 10 was the number you had to use for WEP. So most businesses, what they would use for WEP security when it was first set up, and even home users, was their phone number. Oh, Yelp. Okay, let's see. Here's the number. Whoa, that works. Sorry. The access point devices can hold up to 4 shared secret keys. Again, 90% or probably higher businesses use one key, phone number. One of the keys has to be the designated default. Okay, so here's an example of some WEP keys on the board. On the overhead there, you'll notice these are fairly secure, for 5 characters anyway, WEP keys. You're not going to see these on most businesses. They're not going to use these type. Why aren't people going to use these type of default keys? Why do you think? Human nature.
Can't remember.
You can't remember them. I mean, you can't remember them. Okay? Most IT departments now, what they'll do, especially with the WPA, because they'll have characters, they'll have, maybe, 20 plus characters for a password. They'll physically set up the Wi-Fi for the users before they give them their laptop or whatever it is that has that, Wi-Fi connection in it. The users aren't setting this up. The IT department is, okay? The only one that's going to have an easy password is probably going to be in a business environment, is going to be guests that come in. You have a separate access point, maybe called guest or our guest or whatever, has the word guest in the name. That's going to be totally on the DMZ port that we talked about earlier. DMZ ports do not hit your network at all. So you can set up a DMZ port access point or an access point on a DMZ port for folks to use that are guests, and they can search all day long. They're not going to find nothing. It's totally separate from your network, totally separate. There's a lot of businesses will do that. That's an easy way to set up and to be more secure, and people can still get access to their email and their viruses and to their malware, and they can download them freely and not hit your network. And so that's the way to do it, through a DMZ environment. So when WEP works, this is how it does work. You've got the text, we'll say the phone number. It has a CRC, which is basically a control access algorithm, plugged into the text. Then step 2 has a vector plus a secret key, which is an algorithm basically that they've used. Then the PRNG equals a key stream. The PRNG is a program used within the WEP environment that converts it into a key stream. Then step 4, it does a leftover XOR from what's ever left over from the divisional statement from the key stream. And then you finally have the ciphertext, which is actually goes over the air. This is the part that's hacked right here, by the way. We'll talk about this Thursday more. But the ciphertext is actually hacked because there's only 3 or 4, actually 4 keys, remember, that they can put in a WEP environment. 4 shared keys is a max you can put in there. One of them has to be default. So to do reverse engineering, there's only 4 ways that this can be decrypted, which actually limits the pull a lot as far as how you can decrypt this and crack it easily. There's 4 characteristics of each one of those keys that we'll talk about Thursday that makes cracking a WEP fairly easy. That's why it's important if you have a WEP key to make it a secure WEP key, not a 1, 2, 3, 4, 5 or a phone number. So controlling access on the sending device and receiving device, in between is the part I want to focus on, which is a ciphertext. That's the part that goes over the air. Well, what you're seeing on the top left and bottom right is the devices itself, what they're doing with that information. The top left is what it's taking that key from the WEP, it's converting it to a ciphertext, going over the air, receiving keys, receiving that ciphertext, and reverse engineering that back to the actual text that goes into your router, basically, to see, okay, you're valid, you can get in. But that part in the middle, the RF transmission, that's open air. And there's actual AirSnort is a program that actually we use on Thursday. I'll do a video and show it to you on Thursday. AirSnort is a command prompt app that basically scans your networks. It's a wireless. You have to have a Wi-Fi card to do this using AirSnort. It connects to the Wi-Fi devices on your network that it sees, and then it goes through and sees, number one, what type of security it is. Number two, if it grabs onto, say, a WEP security channel, it hits those first because it's the weakest channels, and then tries to crack any of those cipher shared keys, those shared 1, 2, 3, and 4 keys that are available. And it starts at the top and works its way down. Device authentication through wireless. Wireless LANs cannot limit access to wireless signals by walls or doors, sometimes called data emanation. But you can, they do have such a thing on Wi-Fi access points today that you can level the strength of the signal. And basically what it is leveling electricity of that signal that's hit that signal. And you can tweak it and bring it down to where it doesn't go as far. You can also, on the other extreme, get antennas that are longer antennas that connect to your existing antennas, like say a Linksys routers. You can buy these $9 antennas that are about this long, 2 a piece, plug it into your existing little rabbit ears that you've got. And if you notice the latter year probably, most of your Wi-Fi access points don't even have antennas on anymore. They don't even have them. No. And the reason they don't is most home users don't need them to go beyond 100 feet from the access point. Those rabbit ears that they had on those would actually go, some of them would go on those Linksys routers would go 350 feet, a football field length. What? You don't need it. Okay? So you get the road and the road beyond that, you can see somebody's access point. And so the one thing I will say on that strength, it's called MTU strength in your router. If you guys go home and look at it tonight, don't change that. Okay? MTU strength, you pretty much want to keep it as it is in factory. Because MTU strength, if you play with it, I have seen it make things worse. Now, it's not, you can bring it back to what it was before, the default. Most of the MTU will have a default button. If you mess it up and play with it tonight, most users are probably going to be set on like a 3 or 5. It's like a 1 to 10. It'll be like a 3 or 5 by default. But if you bump it up to 10, which is the greatest strength, it doesn't do anything. And I don't know if it's there but it doesn't do anything or what. But on most wireless routers today, when you play with an MTU strength, which directly magnifies or weakens that beacon, it messes it up. It messes up your data communication. But you can play with it. You can actually look to see if you have. Most of you should still have the MTU strength on your router. And if you play with it, and there's a default button you can press on most of your routers to put it back to what it was at factory, so you're not going to hurt anything. Types of authentication supported by 802.11, the open system and the shared key. The open system and shared key systems are basically this. The open system is, you've got, and you might have seen this when you set up WEP in the past, there's 2 ways to set up WEP, open and shared. On the open, you have a laptop that sends a request frame. So, it says, I need Bill, connect to SSID Bill. The access point responds, says, okay, you're connected, you're done. There's no password. It's open. Okay? You're in an open environment. No password is in there. Now, you are still technically on the WEP channel, though, even though it's open. It's WEP open is what it's called. There's no security. There's no passwords people have to enter in. There is some security over the air, though, on those packets, but it's fairly open. And you maybe went into Wi-Fi, or maybe had yours at home set up for a while like that, to where you can just, people connect your SSID and they're in. There's no, and maybe some hotspots you've been to have done that as well. Like McDonald's has that, I believe. Culver's has a free Wi-Fi. A lot of your coffee shops have them now. Here is a shared key. Basically what it's doing here is the same thing. The laptop's asking for authentication, but number 2 here, it sends a challenge text. The challenge text is pushed through a key. It's encrypted, sent to your access point. The access point compares that encrypted text with its own, and then it determines whether or not it matches. If it does match, it goes back to the authentication device. One of the authentications says yes or no, you can connect. Okay. This shared key is when you set up WEP, you can actually set up a shared key environment, which is those 4 keys. The other way you can do it is in some of your routers, you can actually type in a phrase, and you hit a button, and it populates those 4 keys with some rambling text, basically. All 4 different rambling text. Vulnerabilities of 802.11 security are in the areas of open system, which makes sense. It's open. There's no security to that. There's no password for that. MAC address filtering and WEP. Open system authentication is considered weak because it's only one factor, which is matching the SSID. You see the SSID, it says Bill, you connect to it, you're in. As long as you have a NIC card that talks with that access point, you can get in. The easiest way to discover the SSID is to do nothing on your computer, my laptop or device. With my iPad, if I let it sit there and I walk into a room that has an access point it's never seen before, it'll pop up and recognize it and ask me if I want to connect to it. Okay, same thing with your Windows 7, Windows Vista machines. Once a wireless device is recognized or receives a beacon, it can attempt to join it. And then once you attempt to join it, your computer remembers it after that. So if you do connect to RBC here on campus, it remembers you connected to it today, tomorrow, and maybe have to enter a password in periodically. But if you enter in a password tonight in this room and you go over to CL1, it might have to hit an accept button possibly, but a lot of times you won't have to re-enter that password in again the second time within a 24-hour period. Then passive scanning, this is the most common. It's a wireless device listening all the time for a set period of time, and then it stops listening. So say it listens for a minute, shuts down for 2 minutes. Listens for a minute, shuts down for 2 minutes. For a degree of protection, some wireless access points configure it to where their beacon frame is turned off, meaning the user would have to physically type in the SSID. The problem with this is some of your older laptops have problems with hidden or beacons turned off. Okay? The reason for that is, say you connect to a Bill SSID, right, and you're on an older laptop. It uses that beacon from that access point to see if that connection is still alive. If it doesn't see it, if it doesn't see that beacon, it kills that wireless connection after a period of time and drops it. And you have to reconnect again and again and again and again. So a lot of times you'll see with older, and I've even heard of some newer devices that have a problem with the beaconing turned off, is what I just mentioned. Built into the operating system of that access point, or technically of that Wi-Fi card built into that laptop, needs that frame, that beacon frame, to see if it's still alive or not. Does that make sense? If it doesn't see that, it doesn't get that frame recognition, it drops the access point, drops that connection. And so I don't recommend turning off the SSID because of that in work environments. Because I have seen, again, in a work environment, it'd be nice if everybody had the same machines or the same laptops, but do they? No. Might be a year old apart or whatever. Technically, they're hopefully fairly new, but again, little differences in the NIC cards and how they work. So it's best, it functions best to have that beaconing turned on. I don't recommend turning it off. For home, it might work fine for all your devices at home though. I already mentioned some of these problems, but it can affect roaming. What that means is if you walk out of one room into another room, if beaconing's turned off, it can drop that device from being connected to the access point. Can also affect devices running XP. This is actually the OS that's been targeted as having issues with it. I have seen this as well though on Vista 7. SSID can be easily discovered when it's not connected, or can easily be discovered when it's not contained in a beacon frame. It's still transmitted, but it's in other frames sent by the access point, just not in the beaconing frame. Like in the AirSnort program that I play with on Thursday and show you, AirSnort will notice a non-beaconing SSID easily, because it does show it in other packets as it goes across the air. Configuring an access point to not allow beaconing is simple. There's a checkbox on most of your routers that says turn off SSID, beaconing, turn off beaconing. So here's an access point on the left connected to a couple laptops. One on the right's connected to a couple laptops as well. And you'll notice they're two separate, named two separate SSIDs. They could also be set up in two separate types of security as well. Okay? And I've already mentioned those scenarios why you would do something like this. Also, range is another factor of having multiple access points. If you have multiple buildings like we do on campus, you're going to have multiple access points. Even though they might have the same SSID, you have multiple access points throughout campus just because that one access point only goes so far in the range. MAC address filtering weakness is MAC addresses are initially exchanged in an unencrypted format over the LAN. Here's where the attacker can come in then. They can see by doing an IP config or a scan using a software like Wireshark to connect to an unencrypted. So see if they can't connect your access point, they can still grab onto data coming from your access point. That's how they crack web key codes and WPA codes. So what they're saying is, when that data is coming across the stream, the wireless data, some of that stuff is encrypted, but MAC address is not one of them. MAC address is not encrypted in your stream. So that's easily brought over when you are when you're using MAC address filtering. The attacker can see it because the MAC address is brought across the lines and easily attacked by attacker. And managing a large number of MAC addresses, like in our organization or in a business of, say, over 100 people, would be a nightmare. Meaning I had to have everybody's MAC address in order for you guys to get connected. Okay? That would be a nightmare. And there's some colleges I actually read about trying that. I thought, wow, I'd like to see if that works. The students had to bring in their laptop. In my laptop with the MAC address. You want to write it down? Okay, it's a hexadecimal. What's that? That'd be a nightmare. That'd be a total pull your hair out, shoot me now. I cannot imagine that. But managing a large number would be a nightmare to do. MAC address filtering does not provide a means to temporarily allow a guest in. Guess what this college was doing? Giving out, when a guest came onto campus, they had to get their MAC address from them, and then after a period of time, they had to take the MAC address out of the list. Again, nightmare. WEP, security-wise, they've got a couple things that's going for it initially. One is it is encrypted. The data is encrypted as it comes across. The strength of that encryption is pretty weak. Basically, the short length on that first bullet, the second point on that first bullet, the short length of a default key limits its strength, okay? 5 character, 10 character, fairly limited, all right? WEP implementation violates the cardinal rule of cryptography. Anything that creates a detectable pattern must be avoided at all costs. IVs, or ejection packets, would start repeating in fewer than 7 hours, meaning these supposedly random packets that are sending the WEP key across that are never supposed to repeat originally, repeat after about 7 hours. They start repeating over and over again the data, to where anything that's repeatable in a network or any system can be looked at by a hacker as, okay, there's something going on here that's the same. We're going to track what the sameness is, and then that makes it easier to crack. Does that make sense? If they see a pattern of any type, it's easier to crack. Like I talked about a while back, the banking system's changing their security to what it is today. Makes it easier actually for hackers to crack the passwords because they know it's got to be, 8 characters, you got to have a beginning character that's a caps, you got to have 2 numbers, you got to have a special character. Well, guess what? That just is more information for the hackers to come in and to crack passwords. That's all it is. Same thing with WEP. Repeated things go over and over again. Repeated IVs, which are injection packets over the air. And because of the weakness of WEP, it's possible for an attacker to identify 2 packets because of the repeated nature of the packets. And what happens when they're repeated is a collision happens if you're scanning that environment. So if you use a software like AirCrack, or AirSnort, it'll basically notice a collision, takes that collision, in that collision itself can take and start breaking it apart to crack the password. And that's generally how the password's cracked in the 10-second one I was talking about. Collisions happen fairly quickly in a 5-character password of all characters, like ABCDE. Within 10 seconds, it's already that IV is repeated, not 7 hours, but it's already repeated within 10 seconds, and a collision's occurred. Because you only have 5 characters. There's only so much encryption you can do with ABCDE. There's only so much you can do with that. Keystream attack. This is a method of determining the keystream by analyzing the 2 packets that were created that have the collision. And the term I want you to note on this slide is the XOR. That's what the hackers use. That's what the software use, like AirSnort. The leftover XOR is the number, the keystream number that's used to find the password. There's only so many variations. After they find those variations, they try all of those variations, and one of those variations of passwords works. And all they have to have is one acknowledgement. We have one acknowledgement of that password that they're trying to hack, and then they're in. Okay? So basically the XOR, the keystream X, that's what's actually the key. Keystream X at the top left, bottom right. You'll notice that keystream is the same binary number. Okay? That's what's used as the key to crack the password, is a keystream, the keystream itself. Because what they're looking for in that stream is the key to unlock the password. And a clue to that key is a collision. So in that collision is going to be the key. They have 2 collisions, and the key is the same, like the top and the bottom is the same. They know that's a key used to decrypt or to encrypt that code going across the wires, going across the air. So if it's an ABCDE, there's a key for that. There's a keystream key that's going to be collided in like about a 5-second time period on WEP. They take that keystream, break it apart, and then they can take that keystream and basically reverse engineer and keep attempting to reverse engineer because they already know it's 5 characters. They can determine that easily. Well, the first sweep they try is all letters, lowercase, just so you know. All lowercase A through Z. Well, if you do ABCDE, which most people do, it's caught literally like that. Seriously, just boom, like that's the first sweep, ABCDE, A through Z lowercase. Okay? And it's going to try it in increments of what I just mentioned, ABCDE, then F, and then all the way down to Z, basically. It's what it tries first. When they do numbers, say that doesn't work, and they go from lowercase to uppercase, what do you think the numbers will try first? 1, 2, 3, 4, 5. Exactly. 1, 2, 3, 4, 5 is tried first. And a lot of times that's caught the first time. So basically on these screens we're talking about WEP encryption or WEP capturing packets. The one you want to make note of is the actual key, which in this one is that plain text 1 down there where it says, or the ciphertext, I'm sorry, the 1001011. That's what would be used to crack the code or to crack the WEP key. Then we come to the next 2, and we're going to end on this. It was WPA, WPA Personal Security. WPA is wireless security from the Wi-Fi Alliance, and they began to promote higher security. They knew we needed a higher security than WEP. So these 2 came out first. It's the Wireless Ethernet Compatibility Alliance. The whole reason for that was let's make wireless more as secure, or let's go that route, start going towards that route of Ethernet security, making it as secure as Ethernet. Consortium of wireless manufacturers began to promote this technology The goals: to encourage wireless manufacturer to use 802.11 technology, promote them in the technologies they market, to test and clarify and certify these wireless products adhere to those standards, and ensure interoperability. Okay? And interoperability just means everybody plays nice with each other when it comes to creating NIC cards for the standards that the access points are created for. 2002, the Wi-Fi Alliance, or WICA, was changed to the Wi-Fi Alliance in 2002. 2003, it was, they announced a Wi-Fi Protected Access, WPA. The goal is to protect both present and future wireless devices, addresses both wireless authentication and encryption. And they first came out with that bottom one, which is TKIP, PSK and TKIP. TKIP was actually, when you first used WPA, when it first came out, you had to set that up, then you had to set up TKIP to wrap around the WPA as added security. In fact, when we first got our first document to set up Wi-Fi here on campus with WPA, TKIP, it was 45 steps. Okay? It was put online. Here you go, faculty. Here's the steps, how to set up the new Wi-Fi access, Wi-Fi security. Okay. Now you have to remember now, most people, most faculty, like normal people, right? We're normal people, but non-technical for sure, meaning outside the WTC building, looked at that document and goes, ain't doing it. So it literally wasn't even attempted by over 3/4 of the campus because of the 45 steps it took to do it. Now, when I first attempted to go through the steps, I failed because I didn't follow the guidelines, which is a big surprise, not. The second page, I skipped a step. I thought, I don't need that. I did. I had to go back to the very beginning, start over again. It took me like 30 minutes to connect the first time. And after I connected the first time, I go, this ain't happening. And so sure enough, TKIP, after 6 months of us using it, was changed. It's still embedded in WPA security, but they've since changed it to where it's built in to where you don't have to set it up separately. PSK, on the other hand, uses what's called a passphrase, which we had that as well. We had that as well, which I totally remember now. You had to set up you had to connect to WPA, connect to TKIP, and then the PSK, you had to type in a certain passphrase to add more security to the beginning WPA security protocol. And I think that might have been the step I skipped, was this one right here, the PSK. I thought, well, I don't need that, and I did. And so basically, this was basic. In PSK, a key must be created and entered both in the access point side, so in the access points all over campus, and on all the devices. So it was in the access point, but since I didn't put it on the device on my laptop, it didn't work. It's not used for encryption. Instead, it's just a starting point or a seed value to create random keys, or keys, not really random, because you're typing in the actual seed value for that generation of encryption keys. WPA replaced WEP with the TKIP, which is a temporal key integrity protocol. It does have high security, longer encryption. The keys are known as per packet keys, meaning it's supposed to randomly change each time the packets go across. Those keys do, across the air. When coupled with other technologies, TKIP provides a greater level of security. WPA also replaced WEP with Message Integrity Check, MIC, designed to prevent an attacker from capturing, altering, and resending data packets, or spoofing is what it means. It prevented that from happening. Then WPA2 came out, second generation, much cleaner, easier to use, as you can guess. It still uses a PSK authenticate, but instead of TKIP, it used enhanced data encryption. I think the reason was what I just mentioned earlier. The steps to use TKIP, the manual stuff, was so hard, some people weren't going to do it. And so they integrated that into the security on the new version of WPA2 in 2004. And then this was rolled out pretty much nationwide to small offices and businesses, and they did start using it, and it's been now forward fasting to, if I can get there, to the enterprise version. And that's where we're at today, enterprise WPA enterprise, which is much, I mean, when I use WPA today, I come into the building, even the first time I set up, all I had to do is log in with my E-number, hit OK, yes, I agree to connect, done. That's how much easier it is now with enterprise than it was when we first started with the WPA, TKIP, and also the TSK, all those other steps you had to add in there. Enterprise, though, is only for enterprises, so you wouldn't use this at home. For home, you would probably use up to WPA2 Personal at home. You'll see that on your router, actually. WPA2 Personal, WPA2 Personal is going to be used mostly for home users. Enterprise is just, you have to have an enterprise server on your site that hosts the software to manage WPA Enterprise, which we have here on campus, which makes it a little easier to connect and things of that nature. So, wireless security, are we there yet as far as wired? No. We're getting there though, and the military is actually right now, as we speak, test bedding the newest and greatest next level of security that we'll have. And it'll actually be rolled out probably in the next year. And we'll hear more about it as far as the names that they've chosen for it. All this stuff's still top secret, but the names that they're choosing are going to choose for it. I'm guessing it's going to be even easier than WPA2 Personal and even WPA Enterprise for connectivity, but it'll be tons more secure than what we even have now, which is actually pretty secure. WPA2 Personal and Enterprise is really good, really far leaps and bounds what we had with WEP, okay? So on Thursday when you guys come to class, we're going to do the WEP crack video information using AirSnort. Then we'll break and do the lab for IE security, and we'll end with the gpedit.msc. If you want to do any research prior to now on Thursday, you can probably search a group policy editor would be a good one, and WEP cracking software. One of the ones you can search is AirSnort, is a popular one that we're going to use on Thursday actually. And so that's it. We're all done. If you have any questions, come and see me. Otherwise, see everybody Thursday.